Hello and welcome to our channel where we speak about digital trends and technologies. In this episode, we will discuss the use of machine learning for fraud detection. During this series, we'll discuss different machine learning algorithms and explore the practical applications of ML in various industries. Let's start. Fraud has become a burning problem across different industries. Consequently, businesses have started to explore different anti-fraud methods, including using machine learning algorithms as a tool to detect malicious actors. So, can machine learning systems detect fraud? Yes, machine learning systems have all the required capabilities and processing powers to quickly analyze large amounts of data and identify patterns of fraudulent activities. They are especially useful in industries with high transaction volumes, such as finance or e-commerce. What's more, machine learning algorithms can quickly adapt to changing fraud patterns. They can also learn from new data, a problem that many traditional rule-based detection systems struggle to deal with. What are the benefits of using ML for fraud detection? First, ML provides faster and more accurate detection of anomalies, helping quickly spot deviations from typical behavior. Second, machine learning algorithms can handle enormous volumes of data, which results in better predictions. The more data the model is fed with, the better its accuracy and predictions. Last but not least, machine learning is a cost-effective detection technique. It removes the burden from the team members who no longer need to perform manual reviews and checks every time they receive new data. ML algorithms can analyze this data in milliseconds. In case you are planning to adopt machine learning to your business processes, let's briefly discuss which ML algorithm to use for fraud detection. Supervised and unsupervised learning are the two most common techniques. In supervised learning, all input data should be classified as good or bad. This technique is based on predictive data analysis. The algorithm is trained to clarify data and make predictions based on this information. However, the algorithm has a significant drawback. It cannot detect fraud that is not included in the historical data set from which it's learned. Supervised learning is widely applied in credit card fraud detection, since fraudulent patterns can be learned from an analysis of previous transactions. As for unsupervised learning, it requires neither large amounts of data nor human intervention. The algorithm works with unlabeled and unstructured data, helping discover hidden patterns in it. Unsupervised learning is commonly used when you need to detect patterns in consumer behavior and recommend products that are similar to the ones that are already in the cart. Some companies also apply semi-supervised learning. This technique is used when labeling data is impossible or too expensive, and there is a need for human expertise. And there is also reinforcement learning. This technique teaches itself from its own experience without a training dataset. The algorithm constantly learns from the environment, making various decisions and receiving positive or negative feedback on its actions. A significant disadvantage of the technique is that it involves a lot of computation. It requires plenty of data and has a high maintenance cost. Reinforcement learning can be effective for fraud detection when fraud patterns are not understood. Yet, in most cases, it is better to have supervised and unsupervised learning. These techniques have proven to be more effective for fraud identification. As we've touched on different machine learning techniques suitable for fraud detection, let's discuss some practical scenarios. So, how is machine learning used in fraud detection? A common practical application of machine learning algorithms is using them in anti-money laundering programs, in particular in transaction monitoring. Financial organizations generally use rule and scenario-based tools for transaction monitoring. However, these tools often fail to capture the latest trends in anti-money laundering cases. Machine learning is capable of creating more sophisticated algorithms by using more detailed behavior indicative data. In theory, banks can apply ML across the entire anti-money laundering value chain by combining it with other advanced algorithms to identify suspicious patterns and behaviors. ML models can be also used to detect wash trading. A real-life example is Web3 antivirus. It's an open-source ML-powered Web3 plugin that protects users from signing dangerous transactions. For example, a user wants to buy a non-fungible token. The plugin's ML module scans the NFT, analyzes its previous sales, and detects its involvement in wash trading. As a result, users can get actionable insights before buying the token. Machine learning can be also effectively used to detect fraud on rental platforms. Just like any online business, rental platforms are often the targets of malicious actors aiming at stealing clients' credit card data. Therefore, applying ML for fraud detection is common practice. For example, Airbnb trains ML models using positive and negative examples from previous bookings to forecast the likelihood that the current booking is fraudulent. Besides, ML models can be used to detect fraud in video games. A typical example is account sharing, which leads to unpredictable spending that looks like fraud. By using ML models, you can better detect in-game fraud. For example, Amazon team offers a machine learning solution that helps developers run and train their own ML models to detect fraud. It detects potentially fraudulent activity and flags it for further investigation. So these are a few of the possible scenarios of using machine learning in fraud detection. We hope that you've learned some useful insights about ML models and their possible applications. Thanks for watching, and don't forget to subscribe to our channel. We also invite you to visit our Pixelplex blog, where we regularly publish articles on technology trends. Have a great day. Bye.